Thank you very much. Okay, welcome to this GTAP virtual seminar. Today we have the pleasure of speaking with Drew Schreiber, or listening to Drew Schreiber today on approximating terms of trade effects in single country CGE models, a topic that's close to my heart. He's in comms with the United States Environmental Protection Agency. He's been with the GTAP network for quite some time and is an advisory board member. So without further ado, Drew, please go forward. Thank you very much.
Great. Thanks for that. And let me share my screen. Great. Hopefully, folks can see my slides. I appreciate the opportunity to talk about this paper in this venue. So this paper recently came out in the Journal of Global Economic Analysis at the end of last year. It's joint work with two of my colleagues in the National Center for Environmental Economics, which is an environmental economics shop within the US EPA, in which I work. Before continuing, I just have to mention the standard disclaimer that the views expressed in this presentation are those of myself and my co-authors, and do not represent the views and policies of the US EPA. So just to give us a quick outline of what I'll talk about today, I'll give a brief introduction over the purposes of the paper, kind of the things that we're interested in getting at and some of the results. Then I'll walk through some numerical evidence for trying to capture these term of trade effects in single country models and a way to implement them. I'll then discuss some modeling results and then have a quick discussion at the end. So just to kind of set the scene here, as we all know, as CGE modelers, we're often faced with dimensionality trade-offs. Typically, we'll be approached with trying to answer or provide evidence about some sort of policy, and we want to analyze it within a CGE model. We may think about trying to represent elements of that CGE model in more detail that specifically relate to a particular policy, and maybe some of the sort of tangential details in the model will leave as more aggregate and less highly resolved. And so what ends up happening is that models are typically designed for a specific policy application. And in single country models, the impacts of foreign trade are often simplified by assuming price-taking behavior on the world market. This is the so-called small open economy assumption, or in this presentation, I'll refer to it as an SOE model. It's just something that specifically in non-trade modeling applications, this is something that is sort of a convenient assumption that can be made to analyze domestic policy impacts. This can be appropriate in some cases, say in smaller country applications, non-trade exposed sectors, but maybe not in others. And so, this paper tries to sort of assess what the numerical evidence might be in terms of whether an SOE assumption is appropriate, and in instances when it may not be, suggest a simple approach for implementing a large open economy, or what I'll refer to as an LOE representation in single country models in a relatively simple way. So just by way of motivation, some might be wondering why someone working at EPA, an environmental economist, might be sort of interested in this trade application. At EPA, we have our own CGE model called SAGE. It's a dynamic model of the U.S. economy, and it's geared towards modeling environmental regulatory applications. In 2020, the model was peer reviewed by our Science Advisory Board. And there was a recommendation made that at the time, the SAGE model was a small open economy. There was a recommendation to translate that to a large open economy. And in the report, they said doing so would help ensure the model is able to capture regulatory impacts on traded goods. So when we kind of endeavored, we took this on and we kind of surveyed the literature to see what was out there. There was several studies looking at what might be missed by a small open economy assumption, some papers by Christoph Boehringer and Tom Rutherford, sort of looking at this particular welfare channel. But when we tried to find some empirical evidence on what these specific elasticities that we need to parameterize this assumption into a single country model would be, there was a lot of limited evidence, and a lot of the papers that we found were for specific, very sort of narrow commodities, or they were elasticities that were dependent on trade partners and not necessarily trying to capture this relationship between a modeled country and the aggregate rest of the world. And so that led us to thinking about trying to use the GTAP model to come up with estimates on how to do this. You can think about relaxing the small open economy in several ways in CGE models, and indeed there are lots of applications in the literature that do this. The first and maybe most obvious one would be to just link your single country model with an existing international model. So, there are some papers that do this listed here. One by Justin Karen et al. That link a model of the U.S. economy, looking at California energy policy with the broader GTAP model. There's also this WIN-C GTAP effort that nests the subnational resolution of the data coming from the Wisconsin National Data Consortium within GTAP. So there are some examples here. There are some clear example or advantages in doing this. Primarily you'd be able to capture the full richness of the international economy. But then, there are disadvantages, and you would require sort of the national model to conform to international frameworks. It would likely deal with more complicated solutions, lots of alterations to the model, and then maintenance costs kind of going forward in future model development. And so this kind of led us to thinking about ways in which we can calibrate a reduced form mechanism, which by reduced form, we mean an approach that doesn't necessarily model physical trade, but is more to approximate terms of trade effects or changes in import and export prices. Here, the advantages is simplify the rest of the world significantly, reducing a lot of the model maintenance. But then, there was one potential disadvantage, and that was it wasn't clear how well this sort of reduced form mechanism might perform relative to a full international model. And I've listed some references here that implement some sort of reduced form mechanism, but that don't necessarily answer this question about how well it performs relative to a multi-regional model. And so the main goals in this paper are really two-pronged. It's the first is, can we use the GTAP model, and here we use the GTAP and GAMS framework to simulate and report what export demand and import supply prices price elasticities are for the entire GTAP9 database, to kind of inform this question about where a small open economy might be a reasonable assumption and where it might not be. And then secondly, take a reduced form approach from the literature. We take one from Jim Markison that's later adopted by the MIT US rep model to test the efficacy relative to a multi-regional GTAP model. And just as a preview of results in the paper, we find that the SOE assumption may miss important impacts in export markets and potentially some import markets. Secondly, when calibrated to internally consistent elasticities, we find that the reduced form approach performs really well relative to a multi-country approach. In that comparison, we also find that the SOE model can over or under approximate welfare costs, depending on the direction of the terms of trade effect. And then finally, and this is not something that I'm going to dig into a ton in this presentation because of time limitations, but it's in the paper. But we do kind of think about this question about, okay, the GTAP and GAMS model is static, the SAGE model is dynamic. How do we think about calibrating a dynamic model to a static set of elasticities? Are there ways in which we can think about how those elasticities might evolve over time, depending on differential growth assumptions in the international economy? So we get at this question a little bit in the paper, and we largely find that, at least for the purposes of looking at environmental regulatory scenarios in a US-based model, sort of the assumption on differential growth in the international economy doesn't make a huge impact on some of the calculated welfare effects in the model. So just sort of to set the stage with numerical evidence, what do we mean exactly by the small open economy assumption in single country models? Here are two plots with very simplified linear supply and demand curves for imports and exports. On the left side is for the export market. The bolded lines are what would typically be included in a single country model that assumes a small open economy. And so we have some sort of export supply function that's modeled. A lot of times that'll look like some sort of constant elasticity of transformation function or something to govern sort of how exports are supplied into the world market. And then oftentimes we have a flat export demand function from the rest of the world, and that's operationalized usually through some sort of foreign exchange price in the model. The implicit assumption here is that the price elasticity of the rest of world demand for region R's export of good I, or epsilon, tends towards negative infinity. Really what we're curious about here is, can we use the GTAP and GAMS framework using GTAP 9 to come up with a downward sloping demand curve for the region R's exports, where epsilon is somewhere less than 0, but not negative infinity. On the right side is the import market. It's sort of analogous. In single country CGE models, it's often assumed some sort of Armington aggregator function that brings imports into the country that's then sort of substitutable with domestically produced goods in production and consumption. So there's some implicitly defined downward sloping demand for imports. And then the small open economy would assume that the supply of imports into the modeled country, the curve is flat, and so the price elasticity of supply would tend toward infinity. Here we're thinking about how can we calibrate the supply curve to potentially be upward sloping. So in order to do this, we simulate values of epsilon and eta using the GTAP and GAMS package with GTAP 9. In the paper, we walk through code to implement this in GAMS and MPSGE. But for the purposes of the presentation, I just listed in bullet form kind of the general steps that we take. So in order to do this, really what we're interested in is these price elasticities between some modeled region R and in aggregate rest of the world. And so we aggregate the model to two regions, make sure that the aggregation works and that the benchmark equilibrium is verified. We then perturb existing tax rates by some small number on imports and exports to approximate the changes in the cost of supplying or demanding goods from foreign markets, run the counterfactual, and then we calculate each elasticity at the new equilibrium point as the percent change in export demand or import supply relative to the percent change in price. And I'll just note that the code for producing these estimates are all included in the supplemental files of the paper. So I have some example plots. These are averages for a handful of countries, just to get a sense for what the elasticities look like. For larger economies, or I should first note that these are ranked by import supply elasticities, averages across commodities. Import What we generally found was that export demand elasticities are not super sensitive. They remain somewhat similar across virtually all countries in the data set. The import supply elasticity does change, and it largely depends on sort of the size of the economy. And so, for instance, the U.S. has the smallest import elasticities, and as the elasticities get larger and larger, it seems like, at least for that part of the trade market, the small open economy where eta goes to infinity seems to be a reasonable assumption. It just sort of, through testing our model, we found that import elasticities greater than around 150 or so really doesn't make a huge difference relative to an SOE model, at least for that particular market. We did the same thing for averages for a handful of commodities. We found that, again, the export demand elasticities don't change a ton. I mean, those largely tend to be governed by the assumed Armington elasticities in the GTAP database, whereas the import supply elasticities, it does seem to differ quite a bit across commodities on average. Those commodities that are natural resources or are produced in only a few countries, it seems, tend to have lower elasticities. I should note that for this plot and the previous plot, these are just sort of averages. The outcome of the code would provide elasticities by region and by sector. And so underpinning these estimates are heterogeneous estimates that depend on country and commodity. So we have this framework for calculating what the elasticities are. We then want to apply those elasticities to a reduced form approach. We adopt a methodology in the paper introduced by Jim Markison in 1995, and later adopted by the US REP model, which is a model in the US that's a recursive dynamic model. And the approach largely relies on this notion of fixed factors, where it allows you to calibrate traditionally supply responsiveness into markets. This approach is largely, excuse me, has been used a lot in trying to calibrate supply price responsiveness in natural resource markets and markets that rely on a natural resource like agriculture. But it's also been applied in this trade framework. So just to sort of formalize what we're doing, let PM sub I denote the import price of commodity I, PE sub I denote the export price, PFX is the price of foreign exchange, which is sort of usually how this small open economy assumption is operationalized. And then we add these two extra prices to be prices associated with fixed factors, P fix sub I and P fim sub I, one related to exports and one related to imports. And then we can define a price equation for the price of imports and price of exports, listed here in equation 1 and 2. Notably, as theta sub I m tends towards 0 and theta x tends towards 0, then this approach allows the price of imports to equal the price of exports, which is the PFX, which is effectively the small open economy assumption. And I also should note that for folks that are familiar with the fixed factor representation, um, we assume a Cobb-Douglas function here. Another degree of freedom when calibrating fixed factors is you do have to specify the substitution elasticity. Here we just set sigma equal to 1 for Cobb-Douglas. We can do this without loss of generality here because there's 2 degrees of freedom. We don't know what theta is and we don't know what sigma is, so we pick sigma and let theta adjust accordingly depending on what the price elasticities are that we're calibrating to. And in the paper, we provide proofs for calibrating these thetas, these unknown terms, where theta x sub I equals 1 divided by the negative export demand price elasticity, and theta m is 1 over 1 plus the price elasticity of supply for imports. These equations would change if you change sort of the assumption on sigma, but this is what works for a Cobb-Douglas function. So to get into some modeling results, we approach this through some illustrative policy scenarios that are geared more towards environmental regulatory applications. And so what we do is we look at a $1 billion sector-specific Higgs-neutral productivity shock. These shocks are designed to mimic what an illustrative environmental regulation might look like, where compliance requires additional inputs to produce the same amount of output. In the paper, we choose sectors that have been historically regulated under the Clean Air Act in the U.S. and or represent a significant share of U.S. exports. The shock is meant to just sort of illustrate the model comparison. We don't sort of dig into some of the details of exactly what the economy-wide story is relative to the shock, more to just sort of implement something and then compare several modeling variants to see how well they approximate each other. And so the model comparisons that we do is we have a 2-country model where we aggregate the 2-region GTAP and GAMS model to the US and the rest of the world, and that sort of has sort of the standard bilateral trade as in GTAP. Then we have an LOE version where it's just a 1-region GTAP and GAMS model of the US with this calibrated reduced form framework. And then we have an SOE version where it's the 1-region model of the US and we assume sort of price-taking behavior. These are the elasticities that we use to calibrate the model. The bolded rows are the ones that where the shock occurs. So we implement a shock in the electricity sector, the petroleum refinery sector, chemical sector, and the balance of manufacturing sector. Essentially what the shock does is it makes it more expensive to produce goods in a particular sector, which increases the price of exports. And so here, what you largely see is a reduction in export quantities in the shock sector, and then some general equilibrium multi-sector effects going on elsewhere. Effectively, what the large open economy assumption is doing is it's sort of adding some curvature to the export demand functions, which sort of translates a pure quantity effect into a price and quantity effect. And so what we end up seeing is a larger reduction in quantities in the SOE model relative to the large open economy specifications. And what's also apparent here is that the LOE single country approach mimics almost exactly the 2-country approach. When we look at prices, you see some very, very similar trends. The shock is making it more expensive to produce, and so you see an increase in the export price in the shocked sector, but then some general equilibrium effects going on elsewhere in the economy. And I should also have noted that each column represents a different shock. And so the first column is the shock on bounce manufacturing, second is on chemical manufacturing, and so forth. But again, the price responsiveness in the export market is very, very similar. I should also note just quickly on the price in these price plots, there's no SOE because the prices don't change. On the import side of the trade market, we see that because the import supply elasticities are a lot larger than the export demand elasticities, the difference between the two country and LOE model relative to the SOE model is a lot less. Because the elasticities are so high, the import supply function is almost flat. And so in the quantity space, the differences are pretty negligible. And for price changes on imports, we see a little bit of a difference between the two country model and the LOE model. Although I will note that if you look at the horizontal axes, the numbers are quite small because the price elasticities are quite big. And so the price changes that are going on here are quite small, and it could be sort of numerical differences going on between the two models that are causing this. I also note in the paper that we do illustrate that we're able to calibrate to the own price elasticities almost exactly, but there is some difference in the cross price elasticities between the two country model and the reduced form LOE model, which might be driving some of these results. So finally, what does that mean for welfare in terms of trade? So when aggregated together, the two country and the LOE model produce very similar terms of trade impacts measured as the percent change in the export price index relative to the import price index. Basically the two country model and the LOE model produce very similar estimates. Depending on the shock, you can get a negative terms of trade effect or a positive terms of trade effect, and that translates almost directly into welfare consequences. If your terms of trade effect is negative, it means the price of your exports are falling more than the price of imports, and so for every exported good, you can demand less imported goods, and vice versa for positive terms of trade effects. And you can see that where in the balance of manufacturing shock on the left side, the negative terms of trade effect leads to larger welfare changes relative to the SOE model, whereas a positive terms of trade effect leads to welfare improvement relative to the SOE model. And then I'll note that the electricity sector shock, it's not a very traded good, and so the terms of trade effect is quite small, and the LOE and two country model produce a very similar welfare effect relative to the SOE model here. So that kind of wraps up the static model comparison exercise that we did with GTAP and GAMS. There's a good chunk of the paper that's devoted towards applying that type of framework to a dynamic model. We use the US EPA's CGE model called SAGE, and really this was to kind of get at how appropriate it is to calibrate a dynamic model to a static set of price elasticities for export demand and import supply. Is it reasonable, or does it matter how we think those elasticities might evolve over time? Kind of the standard or default assumption that we make is that those elasticities are flat, they're unchanging over time, and then we we use the static GTAP and GAMS model to see how those elasticities might change by sort of running the static model to hit differential GDP growth targets between the US and the rest of the world, and sort of recalculating the elasticities to see how they might evolve depending on those GDP growth targets. The bottom line that we found is that, at least for the scenarios that we looked at in the paper on these illustrative environmental regulatory shocks in the US economy, the differential growth assumption didn't appear to significantly influence the welfare effects, although you did see some changes and sort of trade behavior. And I would just point folks to the paper if they'd like more detail there. So just to kind of wrap up in 2 slides, to give a brief summary of the paper. We simulate export demand and import supply elasticities for the entire GTAP9 database using the GTAP and GAMS model. We use those estimates to calibrate a reduced form approach in the literature, and then we use that reduced form approach to compare with an internally consistent multi-regional model, and find that the reduced form approach approximates the multi-regional model well in a static setting, and then we do some comparative exercises in a dynamic setting to see what might matter in projecting those elasticities forward. So, just some concluding thoughts here before we get into a broader discussion with the group is that, I think the evidence generated with GTAP9 and GTAP and GAMS revealed that virtually any single country SOE model may miss important impacts in the export markets and some import markets, depending on the region and commodity of interest. I'd also say that the relative importance of this terms of trade effect, I think, is a relatively understudied feature or assumption in non-trade modeling applications. And so, the paper finds that, at least for our illustrative scenarios, introducing this LOE reduced form framework produced anywhere from a negative 16% to 8% welfare change relative to the SOE model, which, is, I think, can be quite significant, although that effect is dependent on the scenario that you're looking at. Another nice feature of this reduced form approach is that it requires little additional modeling and parameters relative to an SOE model. So, essentially, you can translate an SOE model into an LOE model with 2 times n parameters, where n would be the number of sectors in the model or commodities in the model. And then it's easy to check the importance of this particular welfare channel by setting the thetas associated with the fixed factor representation in the model to 0, which effectively converts it back to an SOE model. And so it's easy to kind of get a sense for how much this additional complexity might give you for a particular policy application. That all of that said, I will say that this approach is dependent on Armington elasticities in the GTAP database. And so, should those estimates change, then the resulting reduced form price elasticities that we calculate would also change. So those are my slides. Thanks for listening. I think we can probably open up the discussion, and folks should feel free to contact me with any questions or comments at the email address listed here.
Thank you very much, Drew. That was great and really interesting. I have a number of questions, but I'll ask the floor to please put forward any questions or comments people might like to do. Let me see. I'm a Teams person rather than there we go. Erwin has a question. So the hands come up.
Hi, Drew. Hi, Chani. Good morning. So you rightly pointed out towards the end that the results will depend on the GTAP Armington elasticities, right? So because the GTAP Armington elasticities are long-term in nature, and if you're calibrating it to a dynamic model, what do you think should the changes be for the GTAP part of the run? Do you suggest changing or using short-term elasticities for that? Since you're presumably running, if you're going to run a dynamic model, you'll run it either on a year-on-year basis or on a 5-year time step, right?
Yeah, that's a good question. So we didn't really get into how the Armington elasticity should evolve over time. Really, what I've treated those as sort of fixed or gospel. And then basically in the paper, what we do is we look at how economic growth might affect things. So like, as the supply of a particular commodity changes over time relative to the rest of the world, those price elasticities are a function of both the Armington elasticity and sort of, the relative amount of supply and demand in the economy. In fact, there's some work by folks in Australia, and there's a paper linked in cited in the manuscript that I think they came up with a closed form function for how to translate sort of what's known about the current economic benchmark and the Armington elasticities into these export demand elasticities. I think probably thinking about how trade elasticities evolve over time is something that all modelers probably have to confront. I know for us, we've used the long-term GTAP estimates in our own model. But aside from those answers, I'm not sure what else to say.
Thanks, Drew. Yeah.
Yeah, thank you for the question.
Next, another question or comment from anyone? Give it a second here. I was just going to ask briefly, Drew, about just kind of general equilibrium versus partial equilibrium elasticities. You're perturbing and getting an elasticity back out. Yeah, and when you perturbed, what was the closure that you were placing, and were you fixing factors and perturbing, or having factors mobile? How did that work when you're perturbing to come up with inside the GTAP and GAMS?
Yeah. Well, so we actually did it two ways. The way that we ultimately decided upon in the final version of the paper was we used tax rates sort of on exports and imports. We perturbed tax rates to approximate the changes in the cost of supplying goods to foreign markets. And we left the model sort of as is. I didn't try to close it because I thought it would be important to capture sort of these general equilibrium effects implicit in the price elasticities that we would rely upon. And it turns out looking at the comparison between the modeling types, that it seems that was an appropriate assumption to make because the models, the outcomes were so similar. I will say the first iteration of this paper, excuse me, was I ended up fixing export and import prices, just sort of perturbing a fixed import or export price by a tiny amount, and then recalculating, and then calculating what the implicit price elasticities would be given that exogenous change in the price. And it was pointed out in the review period that this effectively sort of creates a disequilibrium in the model because those fixed prices are associated with complementarity conditions, and then because we're fixing the price, those complementarity conditions are no longer in equilibrium. And if you use the wrong variables when you're calculating the elasticities, you can get some sort of different estimates because those essentially those market clearance constraints are no longer being enforced in the model solution. And so, as long as you're careful, they both are roughly the same, but it's just something that we had to sort of kind of take care and think about when generating some of these elasticities. But in terms of like model closures, yeah, I mean, we tried to include sort of all those general equilibrium effects and wrapped up in the estimates.
Okay, I have another one. I presume if somebody's hand goes up, I'll see it across the top of the screen here. But if you would just for people on the call, go ahead and just sort of reiterate the reason why you did this, right? Which is basically it's enabling you to run Sage more easily. So this would apply to other places in the world as well. And what are the conveniences that and the advantages that you've perceived? You went into that, but not very much. Okay.
Sure. Yeah. So we were confronted with this problem of wanting to capture price responsiveness in the rest of the world in our single country model that is complex enough that we would never be able to link it directly with, say, the GTAP model. And so we wanted to get sort of elements of the GTAP model within our own domestic model. And so we were really kind of geared towards trying to come up with a way to credibly calibrate a reduced form mechanism in the model to capture some of these effects. And what I think is cool here is, in the paper, we generate elasticities for every commodity and every region pairing in the GTAP database. For anyone that has a single country model and that is a small open economy model, you could take those elasticities and fold them in with only a couple extra lines of code essentially to capture some of these effects. The fixed factor representation, we felt was a nice one because you could essentially just take those elasticities, calculate what the value shares are in the pricing equations, and then you'd have this full large open economy specification. And it doesn't add much to the programming. It doesn't add much to the model solution, at least in our experience. And so it seemed like a very simple but credible way to capture some of these effects. And given some of the estimates that we found, it does seem that at least on the export side of things, this could be an important thing for folks to think about, regardless of sort of which country you're trying to model.
Okay. Yeah, thanks. Here there's a note from somebody in the chat coming out. And then sort of this leads us, it seems to me, which is kind of my last point, towards, I'm wondering what kind of just validation exercises you've done with Sage in terms of running it against history in the US and moments when there have been perhaps big movements in price. Have you given that a go? So that goes towards kind of Erwin's question of not taking the GTAP armings and elasticities as sort of gospel here, but just kind of checking out what the US, how the US economy might have bounced or changed as a consequence of different shocks with and I do think that international price shocks are pretty good candidates for trying to identify some of these underlying parameters in the model, because it is fairly exogenous, though it does drive alpha. But in sectors in which you're interested, the petroleum being quite variable and also of a lot of interest, both in terms of but in derived products to US EPA. And I'm just wondering if you guys have what you've done and how you've thought about that.
Yeah, that's a great question. So We haven't done a ton of like so-called retrospective analysis with the model where we spend quite a bit of effort parameterizing it as best as we can given empirical estimates of elasticities and projections and things like that. We haven't done a ton of work trying to verify some of the model outcomes based on previous shocks. Although your idea about international price shocks is an intriguing one. What we've largely done is spent quite a bit of time trying to make sure that the model looks credible going forward. So sort of the opposite of what you're talking about, but we've couched the model and using a variety of projections that are reported from the U.S. government on things like energy efficiency and labor productivity and other projections. But I could see sort of that being a useful exercise to conduct and sort of the next steps and especially related to these trade applications. So it's a good thought and something that I think we could work towards.
Okay. Yeah, we'll be happy to done it for other typically smaller countries, and it would be interesting to think about for the U.S. Is Sage in GAMS? Just I don't.
It is.
Yeah. Okay. So we have GAMS code that kind of sets stuff up, which you might be interested in at some point.
Yeah, absolutely. I'll follow up about
that. Yeah. I think you've impressed them with your clarity. I'll ask around again, maybe Erwin or anybody else. Any further questions or comments for Drew? Go ahead.
Just a quick one, which Channing alluded to. There's this book published by the World Bank and edited by Tom Hurtle and Alan Winters way back in 2006. So in that book, there are about 10 papers, I think, that link GTAP with single country model using export demand elasticities. That is to have a better link of Doha development agenda and poverty and inequality, but that might be of interest to you as well.
That's great. Yeah. And it sounds like if it's not cited in the paper already, it should have been. So appreciate that.
Well, this is fantastic, and I think we've met the goal here of these seminars, which is to get across at this time a pretty technical point. I confess that I didn't have very much of an idea of what exactly EPA did with their CGE models, and so I've learned a lot just in terms of, okay, I thought it was really interesting. Okay, we're going to take a $1 billion productivity hit and see how that moves through the economy across various. I'm like, okay, that's a very sensible way to go about that. So it was really interesting for me. And thanks to you, Drew, for volunteering to do this seminar as part of this series. Thanks to Ginger for organizing. Thanks to everybody for attending. Ginger, do we have I'm sorry to bother you with this. I'm not aware. Do we have a next one already programmed, or will we just wait?
We do. So on April 8th, Maxim Shepliev is going to present on the GTAP circular economy database, which is timely. That just was released, and we will advertise and start taking registrations for that in early March.
Okay. Fantastic. So we'll hope to see many of you for Maxim's presentation in April. Once again, thanks to Drew and to the rest of his team. It's not a sole authored paper, it's sole presented. So thanks a lot to everybody for attending, and we'll look forward to seeing you all in April and at subsequent ones of these. And of course, these are done to be of value to the network. So any comments on how we can do a better job to serve the network with these less frequency, more frequency, more detail, whatever it might be is welcome. And I'm sure Drew would appreciate the feedback as well. So yeah, please let us know if you have any thoughts on any of these, and we'll look forward to seeing you at the next edition. Thank you.